Hello, dear students. So now today we would move ahead in this first chapter of class 12th chemistry, that is solid state, where we were discussing the types of solids. We have already discussed crystalline solids, amorphous solids, and the types of crystalline solids that also we have discussed. So today I have some questions for you. Here you have to tell that which type of solid are these. Okay. Now if you see P4, that is phosphorus. So phosphorus is which one solid? Can you tell me? If you see, the phosphorus molecules are joined together by the weak van der Waals forces. So hence you would be calling phosphorus as molecular solid, isn't it? So phosphorus is what? Molecular solid. Then you have NS4Cl. So it is in ion form. It can be written as NS4 positive and Cl negative, isn't it? So hence you would be calling NH4Cl, that is ammonium chloride, as ionic solid. So NH4Cl is what? Ionic solid. Then you have sulfur. Then again, if you see, the different molecules of sulfur are joined together again by the weak van der Waals forces. So again, you would be calling sulfur as what? Molecular solids. Then you have polythene. So polythene is what? It's a polymer. Polythene is what? It's a polymer. And we have already discussed. Polymers are what? Amorphous solids. Polymers are what? Amorphous solids. Because the arrangement of particle is not same there. In case of amorphous solids. So polythene is what? Amorphous solid. It's the example of amorphous solids, pseudo solids, or you can call it super cool liquid. Okay. Then you have sodium. So sodium is what? It's a metal. Sodium is what? It's a metal, alkali metal. So you'd be calling sodium as metallic solid, isn't it? Yes. So it's the example of metallic solid. So this is how you would give the answer of these given questions. Okay. Okay, just note it down. Then after we would be moving ahead. So now we would be discussing these two properties, isotropy and anisotropy. So if you see anisotropy, it's the property of some solids where the solids do not show similar properties from all its directions. Means if you are measuring a property such as electrical resistance from this one direction and from this one direction, you would not be getting the similar result. Okay, means it would not be showing the similar property such as the refractive index, or you can say electrical resistance from these two directions. Okay, so such solids are known as isotropic in nature. Means here the solids do not show similar properties from all its directions. For example, the crystalline solids. So if you see the arrangement of the particles in case of the crystalline solids, the definite arrangement is there, isn't it? Yes. But if you are measuring the property from this one direction and this one direction, you would be getting the different result. Getting it or not? So you would be calling crystalline solids as anisotropic in nature. Are you getting it? So crystalline solids are anisotropic in nature. Then you have the next property, that is the isotropy. So again, isotropy is a property of some solids where the solids shows similar properties, where the solid shows similar properties from all its directions, such as conductivity. If you are measuring the conductivity from this one direction and from this one direction, you would be getting the similar result. Okay, so such solids are known as isotropic in nature. So we have the example of amorphous solids. So amorphous solids are isotropic in nature. If you see the arrangement of the particles, so you would have the arrangement like this. Means the definite arrangement is not there. But if you are measuring conductivity from this one direction and from this one direction, you would be getting the similar result. Again, if you are measuring the conductivity from this one direction and this one direction, again you would be getting the similar result, because ABA is from this one side also, from this one side also. Are you getting this? Are you getting? Yes. So such solids are known as isotropic in nature. So amorphous solids are isotropic in nature, whereas crystalline solids are anisotropic in nature. So if it is being asked in the exam that differentiate between crystalline solids and amorphous solids, so you can differentiate it in two ways. First one, arrangement of the particle, which is definite in case of crystalline solid and which is not definite in case of the amorphous solid. This is the first one. And second one, crystalline solid shows the property that is anisotropic property, and amorphous solids show isotropic property. Means amorphous solids are isotropic in nature. So this is how you can differentiate between the crystalline solids and the amorphous solids, okay, on the basis of these two properties. Okay, so now just let me write it down here. So these are the two properties of crystalline and amorphous solids. So crystalline solids are anisotropic in nature, that is, some of their physical properties such as electrical resistance, refractive index shows different values when measured along the different directions. So you will be getting the different values there. Okay, but in case of the amorphous solids, you would be getting the similar result when you are measuring these physical properties from all the directions. Okay, so that is why amorphous solids are isotropic in nature and crystalline solids are anisotropic in nature. Okay, that is all for today, and would be discussing some more topics of this chapter in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.